My name is Michael Hall. I am a developer advocate and community manager for InfluxData. Before that, I was working at the Linux Foundation on the LF Edge projects. And before that, I was working on the Ubuntu community when they had just started getting into IoT with the Ubuntu core products. So I've been involved in IoT in one way or another for many, many years now. And I'm really excited because I feel like things are really starting to come together for the IoT space and the edge to cloud space. And I'm excited to be a part of that. So in this talk, I'm going to go over how you can use InfluxData and its related technologies to get data from your sensors on the edge all the way up into your cloud quickly and easily. But first, I'm going to start with an IoT story. And anybody who's been involved with IoT, industrial or otherwise, this will probably be a familiar story to you. But an IoT story always starts out with some kind of a device somewhere. You've got a sensor attached to some kind of equipment that is producing some kind of output. And you want to get that output to your end user, whether it's a person or an application or a system. There's some remote place that you want to get that data to off of that sensor itself. And so this is your story. When you start out, this is what you want. This is the product that you plan on building. A device collects data, sends data to an endpoint, something happens at that endpoint. That's it, easy and simple, right? So the first thing that most people do is they start off with a database. Usually it's up by where they want that data to be, in the cloud, behind an application, somewhere up there. And they just have their data coming from the sensor going directly into that, which is all great when you're developing it locally in your lab or your home office or somewhere you're all on the same network. It's all working great. So then you start adding some additional devices on there, and they're talking to that database, and then that database is going to power your application. And you add more and more devices, and they're all talking together, and it's all going great until you decide that you want to actually deploy this out into the wild. So now you've got a wireless connection or a LoRaWAN connection or 5G or something that all of these devices are having to talk to before they can get to that database that's powering your application. And the problem is that communication line is often unstable. It'll go down, it'll be laggy, sometimes it says it's up, but data's just kind of going out into the void somewhere. And with a really simple setup, your devices are still feeding data into this connection, and it's just going nowhere. It's not getting to your database, it's not powering your application, it's just getting completely lost. So then you end up putting something in front of that wireless connection or that unstable connection, and you start feeding your data into it instead. And it's going to collect your data, and it's going to store it locally. It's going to try that unstable connection and forward that onto your database when it can. So a little more complex, but you've still got data coming in. Except for one of your devices speaks OPC UA, another device speaks MQTT, third one speaks Modbus, or one of the other 24 different IoT protocols that are out there that all of this equipment speaks to. And you end up with this whole group of different protocols, different formats, different ways of accessing your data. And you want to put all of that together, so you end up having to have an additional service that knows how to speak all of these different protocols and to be able to bring all of them together and to transform them into the same kind of data, the same format of data that you ultimately need to pass up through your edge gateway over your wireless connection up to your database in the cloud. So you've got another component there that's going to do this translation on the edge. Then you've got people who are running your cloud service. They're looking at the database and they say, hey, I want to see exactly what data is in there. Whether they're operators or they're developers, they want access to the raw data, not the application that's being presented to your end users. So they want to be able to get a view of your data as it is in the database with dashboards, with tables, queries, whatever. They want to get direct access to that. Then on your edge side, in your factory, in your farm, your smart building, you've got local managers there who want the same thing. They want to be able to look at the data that's being collected on their site. They want to be able to make queries against it, see what's happening there before it goes out to your cloud, before it gets up to your application. You also find out that you want to do something to gain insights from this data. It's not just enough to throw it out there in front of somebody. You want to analyze it, you want to transform it, you want to do predictive analysis on it. So you've got to have some kind of code running there up in the cloud that can give you that kind of information out of the database. And then again, You want to do the same thing on the edge. You don't want to wait to, if you've got a piece of equipment that's getting too hot or starting to vibrate a little bit too much, you don't want to wait for that information to go all the way up to the cloud to do your analysis in the cloud to find out that something's about to explode. So you want to be able to do this here locally on the edge too. So you got to have a way to run, again, analysis code, processing code, transforming code there on the edge. So this is what you end up having to build. But this is what you started off wanting to build. Like, this was your product. This is the only thing you ultimately cared about at the end of the day. This is what you're selling. This is the reality of what you're faced with that you have to do in order to make this possible. So what can we do? What can we do to make this easier? Well, that's where InfluxData and Telegraph and the Flux processing language comes in. So the first thing we're going to do in this kind of setup is we're going to drop Telegraph right in here. Telegraph has a bunch of different plugins that speak different protocols, so you don't have to do your own custom code. You don't have to understand these protocols and how to parse them and everything. We'll do all that for you. And then Telegraph very neatly sends that up to InfluxDB. So you stick InfluxDB on your edge gateway, you point Telegraph at it, and it's collecting metrics data, transforming them, and storing them in a local database for you. From there, you can tell the InfluxDB instance in your gateway about your InfluxDB instance in the cloud. And it's going to handle sending the data from the edge up to the cloud. Even when that data connection goes down, it'll keep storing it locally. When that connection comes back up, it'll know exactly what it needs to send up to the cloud. You don't have to provide that information. You don't have to provide a system to handle that or to keep track of what needs to be sent and what doesn't. We also have the Flux programming language, which lets you add logic to the edge to transform that data, to manipulate it, to downsample it, which is a big thing, even to alert on that there on the edge to get insights about what your equipment's doing. And the same language can be used up in the cloud to perform more complex analysis, more CPU or memory heavy kinds of algorithms that you can't run on your edge gateway hardware, but you can in the cloud because cloud compute and cloud storage is really, really cheap. All right, so why would you want to use a time series database for this at all? A lot of people, they're not familiar with time series databases. They just think of databases as databases. It's, you know, the Postgres, SQL, or maybe Mongo database that they're familiar with. It's a place to store data, and they just use what they're familiar with. So why would you want to use specifically a time series database? So when I first joined the company, right before the pandemic hit, we had an all hands. And I got to share a taxi ride back to the airport with our CTO and founder, Paul Dix, who is the one who originally wrote InfluxDB. And in one of his talks there, he had said that he predicted IoT data was going to quickly overtake monitoring data as the biggest source of data running on InfluxDB. So riding in the taxi back to the airport, I asked him, I said, Paul, what makes you so confident that IoT data is going to be so big? And what he told me was that sensors speak or sensors speak time series. That was his quote. Sensors speak time series. And it's true because whatever your sensor is reading is, the value is completely useless without the context of a timestamp. So every sensor, no matter what you're measuring, is going to have a timestamp attached to that data. And just about everything you're going to want to do with that data is going to be based on the timestamp as much as it is the actual value that you're recording. So there's going to be millions, maybe billions of IoT devices, and every single one of them is going to be spitting out time-stamped data. So there's been a kind of evolution of databases. Like I said, a lot of people are familiar with relational databases. That's all they think about when they think about databases. They've been around for a really long time. They're what powered most of Web 1 and Web 2. The big ones for that are like Postgres. And they're really based on tables and rows and relations between rows and between tables. And that worked really well until people started having these big blobs of data, unstructured data that they wanted to collect and store in a database. And you could put them in a blob field or a JSON field in a relational database, but they're really not designed for that. So then we started to see these big document databases, these schemaless databases, these NoSQL databases. Mongo's the biggest one there. There's also like Couchbase. in that space. And they were really good at storing large pieces of unstructured data. You didn't have to predefine a schema. You can do all kinds of searches and manipulations based on just what kind of data is in there. And they worked really well for that. But then as people started storing more and more data in that, they found that it was getting harder and harder to find what they wanted. So then we saw this third generation of search-based databases for things like logs or geolocation data, where they're optimized to be able to find things among this huge mass of data. And things like Elasticsearch, which really took the throne on those. And more recently, we've seen the rise of time series databases that are specifically designed to handle this timestamp data and the kinds of workloads and analysis that people want to do on timestamp data. And so far, InfluxDB is at the top of that particular category by a pretty good amount at the moment. So people ask us a lot, like, what's our biggest competitor? And it's really one of these other categories. It's people who are used to Postgres or used to Mongo, and that's just their go-to, and they want to throw time series data into those. And you can make those work. It takes some manipulation. It takes a lot of configuration and code on your end to make them work, and they're never going to work quite as well or quite as easily as a database that was designed from the ground up to handle that kind of data. So this is what the InfluxDB platform looks like in a nutshell. At the nucleus of it is the InfluxDB database itself, and then the Telegraph agent, which is a completely separate binary that you can run to collect data. So Telegraph, like I said, collects data from a bunch of different sources, and it'll convert it to output it to InfluxDB. There's actually about 100 different output plugins that you can use for Telegraph, not just InfluxDB. You can send it to a number of different places, even competitors of ours. That's okay. It's our open source project, and we maintain it for everybody. You can also use client libraries that we provide. There's a lot of third-party applications that sync directly to InfluxDB. They know how to communicate directly to it. But this is the basis of the platform. This is kind of the configuration that you'll use. All right, so putting all of that together to actually form a solution for you. Like I said, the first place to start is Telegraph, because you're starting with your sensor data, and you're starting with whatever protocol or format that it has, that it's outputting its data in, and you need to get that into InfluxDB somehow, and Telegraph is by far the easiest way to do that. Like I said, there's hundreds of plugins. Most of them are contributed by members of our community. A lot of times they're contributed directly from the companies that are backing these protocols. So we've had people from Microsoft or from Amazon who are directly contributing plugins to InfluxDB, or to Telegraph, to make those integrations easier, and they actively maintain those plugins as well. So this is an example of the MQTT plugin. It's all configuration based, so you don't have to write code. You just configure Telegraph to say which plugins you want to use and how it should use them. So for MQTT, you tell it where your broker is. You tell it how to find the specific topics you're interested in. There's a bunch of other configurations you can do, but this is just a high-level view how you do that. So you have an input plugin. You can then send your data through a number of different processor plugins, which will transform it in flight in Telegraph before it ever gets stored anywhere. If you want to do some transformations, we've got like a regex plugin where you can just run it through a regular expression to transform it. There's also a Starlark plugin where you can actually run a bit of Python code on that data as it's passing through Telegraph to transform that. Once it's in Telegraph, then you can define one or more output plugins, and this just tells Telegraph where to send the data when it's done handling it. Like I said, there's an InfluxDB output plugin, and all you have to do is point it to your URL for your InfluxDB instance, give it your authorization token, your organization name, and what bucket you want to write it to. And in InfluxDB, a bucket is like a database. It's just a place to store data. And in InfluxDB, you tell it how long you want to keep data in that bucket. So unlike the other like traditional databases where you want to keep data until you explicitly delete it, with time series data, a lot of it naturally has an expiration, and you don't care about it after a certain amount of time. So like if you know you're collecting high precision data and it's only going to be relevant to you for the next 24 hours, you can tell InfluxDB that, and it'll automatically drop it for you after 24 hours. You don't have to have a separate script to do that deleting. So this is basically it for Telegraph. Input plugin, output plugin is really all you need, and it'll handle the rest.
Does it always have to expire?
What?
Does it always have to expire?
No, you can set it to not expire if you want to just keep it around forever. There are better ways to do that, which I'm going to touch on in just a second, because you typically don't want to keep your raw data around forever, especially if you're collecting it at a high frequency. So I'll touch on that in just a second. But once it's in InfluxDB, we have a UI, a web UI that you can connect to, and you can start exploring your data. We make it really easy to drill down into your bucket, into your field, look at the specific measurements you're collecting. And when you're doing this point and click stuff, it's actually building the query code for you so that you can copy paste that into your application, and makes it really easy. You can visualize the code either as a graph or as a table as you're building that out. So it's a really great way to explore the data once you have it in the database. You can also build persistent dashboards using this. Typically people used to use Grafana as a front end for InfluxDB, and still do quite a bit. They have a lot more visualization options than we do, but if all you need is a basic dashboard with some graphs, some gauges, maybe some giant numbers telling you if things are good or bad, you can typically do all of that now within InfluxDB itself instead of having a separate instance to run Grafana in. And the Data Explorer and these dashboards, they're all backed by Flux. And Flux is our new domain-specific language for processing time series data in InfluxDB specifically, but it's actually a separate project from InfluxDB and could be integrated with any other application or database that wants to use it. And the basis of Flux is that you have a series of functions, and you pass data through these functions, and each step transforms it in some way until it's exactly what you want it to be. You can use it for simple queries like this. This could replace like a basic SQL-style query of your data, where you just say, I want to look in this bucket in this time range. Here are the specific values for certain fields that I care about, so you can filter the data down that way. And then at the end, I want to just calculate the mean average for that data. But Flux can do quite a bit more than that. And one of the things that it can do is creating tasks that run in the background within InfluxDB itself. So you can schedule these Flux queries to pull data, to transform that data, to perform analysis on it. You can downsample it, which is what I was talking about earlier, where you've got like high frequency data coming in maybe every second, every microsecond. We've got customers who have like nanosecond precision data that they're feeding into InfluxDB. So you could quickly generate gigabytes or terabytes of data at that frequency, and you don't want to keep those around forever. So a downsampling task will look at that code over the past minute, and it will perform some kind of aggregation or compression on that data to get it from thousands or millions of records down to just one or a handful of records. And those are the ones that then you can store in a long-term bucket. So a typical strategy is to just look at a particular window of time, like the last hour, calculate the average of a set of values over that last hour, and store that average in a separate bucket that's going to stick around longer. And again, all the other data you don't have to worry about. Influx is going to clean that up after you, no problem at all. You can also use tasks to respond to data. So if you notice a certain pattern or something's gone over a specific threshold and you want to trigger calling out to another API endpoint to shut down a process or stop your factory line or something like that. You can do all of that within a task in InfluxDB, and InfluxDB handles scheduling these for you, so you don't have to have a separate cron system or a message queue or something to run these tasks in the background. And in fact, alerting on data is such a common thing for people to do in InfluxDB that we've built a web UI around that specific use case. So we make it really easy. There's a similar query builder where you just select the fields that you want to trigger on. You say what thresholds on those fields you want to count as different states. The default ones are OK, warning, and critical. So you can just move the threshold bars up and down to where you want it to be, and then you can define what you want to happen when it enters that state. We've got plugins for things like PagerDuty, for Amazon SES, for sending text messages, or for just sending an HTTP request. Like I said, if you've got an API endpoint that you can hit to trigger some response based on your data, you can set that up too. And what this is going to do in the background is it's just going to generate you a Flux task. It's going to generate the Flux script that you need. It's going to create a new task for it and do all of that for you. So for simple stuff, for looking at threshold checks, you can do that through the UI here. If you want to set up a dead man check where you don't care what the value of the data is as long as there are values continuing to come in. But if you suddenly stop getting data from a sensor, you want to know about that. You can set up a dead man check to get alerted for that. And then anything more complex, you can just write your own task to do that and use Flux to do as much complex analysis as you want to do. We've done like standard, like median average deviation, so that if you don't know the threshold, but you know if it goes a certain point over the norm, that you want to be notified of that, you can do that in Flux as well. And then once you've got the data where you want it to be, you want to get it off of that edge gateway and into the cloud. And I don't really have any really cool like visualizations or anything to show because it really is just super simple. There's a two-step process. You say what remote server you want to send data to, and you say what bucket you want to send data to, and that's it. And the InfluxDB is going to handle the rest for you. It's using a durable write queue. So anything that you're writing locally that you're wanting to sync up to the cloud, it's going to keep a copy of that until it can send that up to the cloud. So if your connection goes out, like I said, you're not going to lose that. If your power goes off and your gateway shuts down, hard shuts down, not even a clean shutdown, you've got that data still on that device. And when it comes back up and it makes that connection again, it's still got that data and it's going to sync that data up to the cloud. So you don't have to worry about losing your data no matter what happens. It's flexible because you can specify what buckets you want to sync, and you can combine that with one of those downsampling tasks. So you can have a bucket with your raw data that is not being synced. You can have a bucket where you're sticking your downsampled data and you say, okay, this is the bucket that I want to sync up to the cloud. So only your downsampled data is going to get written up there. And it still lets you retain the local data, the high precision data locally that you want, even the downsampled data locally, so that you can alert based on that on the edge and not have to wait for that sync to go up to the cloud, for the analysis to run there, and for it to come back and say, hey, your plant's about to be on fire 30 seconds ago. If you were writing your own application, which most of our users end up doing, either on the edge or as a website or something in the cloud, we have about a dozen different client libraries that make it really easy, no matter what your preferred language is. And each of these client libraries is designed to feel natural in that specific language. So our Python client library makes you write code that feels like Python code. And our Java library makes you write code that feels like Java code. So you don't feel this mismatch that you can sometimes have with client libraries. We even have an Arduino library. So if you're prototyping with like an ESP32 or an 8266, we've got a library that works really well with those. Lets you connect over their wireless chip to an InfluxDB instance, and you don't have to do it over the serial console, which is really cool for prototyping. We also have a Visual Studio Code extension, which is really popular with software developers. And it does a number of things. First, on the left-hand side, it'll let you browse your data schema in a remote InfluxDB instance. So just like with Telegraph, where you point it at a URL and you give it an auth token and an organization name, you do that when you set up the VS Code extension. And here it'll show you all of the buckets that you have in that remote instance. You can open one of them up and see what measurements you have. You can open that up and see what fields you have. And you can use that to write your Flux query within Visual Studio Code. It uses the language server protocol that Microsoft developed, so you can actually get code completion and suggestions and inline documentation for Flux within Visual Studio Code. And then my personal favorite thing that you can do is you can execute one of these Flux queries from Visual Studio Code through that remote instance that you set up and get the data back in a table in another tab like it's shown right here. So as you're writing your application code and you're writing your data query, you can very quickly see what that query is going to return to your application code so that you know what you have to work with. And lastly, we've got a really big community of users and supporters. We've got 28,000 people now in our online community. So you are not going to be alone when you start on this journey. There's a number of IoT experts, people in like some of the big IoT companies who are willing to share their expertise. Like I said, a lot of them are contributing code to Telegraph to make interoperability with their systems a lot easier. So our big platforms are GitHub. Just about everything we do is open source. MIT is our preferred open source license. InfluxDB itself is MIT. Telegraph is MIT. Flux is, I believe, MIT. We've got a new data storage backend that we're working on. It's written in Rust, and it's using the Apache Arrow and Aeroflight and Parquet formats. That, I believe, is Apache licensed so that we can easily share code back and forth with those projects. And in fact, we're big contributors to those projects. Again, all of this is up on GitHub. InfluxData is our organization there. You can find all of our code. The biggest places we have community people aggregate is our Slack, which is you can get to from influxdata.com/Slack. It's open to anybody. And then we've got a community forums where a lot of people go to post questions and get those answered. And what I really like about our forums is we've integrated them into our support portal now. So as questions get answered on the forums, they will be pulled into the support portal, and when somebody searches for help there, it will pull up these answered questions from the forums as a result. And in fact, that's the biggest source of people finding answers is coming from questions that get answered in our forums, and the majority of those are being answered by members of our own community, not even our staff. We do have a subreddit. It's not very active, but if anybody here is a Redditor and wants to participate there, post there, ask questions there, we do have that at /r/InfluxDB. We also monitor the InfluxDB and FlexSlang tags in Stack Overflow and also on Twitter. So lots of places you can find us. I do encourage you to get involved. I'm on Slack all the time. So if anyone's starting on this journey and has questions, you can come find me there.